Bueno, hemos llegado a la última presentación de este webinar, que en realidad tiene que ver con un tema de vigilancia, ya donde Brighton Chang nos expondrá la ponencia titulada Contador de piojos automático, experiencia y resultados en Noruega. Brighton es ingeniero de la Universidad de Princeton, cofundador y CEO de Aquabite, la cual es una empresa respaldada por Silicon Valley, con sede en Noruega, que aplica Machine Learning y visión computarizada en la producción acuícola para la estimación de biomasas, conteo de piojos y la optimización de la alimentación. Dejo con ustedes a Brighton para que nos cuente este sistema de solución a través de Machine Learning en el conteo de piojos. Está ahí con el micrófono desactivado, Gonzalo.
Perdón. No, les comentaba que voy a agradecerle a Brighton, él nos acompaña desde Nueva York. Ha estado muy atento todo el webinar y es la presentación perfecta, en mi opinión, para dar un cierre en el que vemos cómo la tecnología y la aplicación de altos niveles de ella es una herramienta del futuro, pero disponible hoy. Well, thank you very much, Brighton, for waiting with us through all the webinar. I was telling all the audience that you are with us from New York, and that is the perfect presentation to wrap up this webinar, because you're going to show us how the technology show us the future today, available to help us out in different matters and surveillance of this disease and something else. Please, Brett, go ahead.
Gracias. Mi nombre es Brighton Chang y soy el fundador y CEO de Aquabite. I'm really excited to chat with you all today a bit about how we've helped and worked with farmers and how we can help with control of Caligus and how it can help farmers in Chile. And excited to share a bit more about our experiences in Norway and Chile and other countries as well. So just a bit about the company. You may have heard we're a company. We started in Silicon Valley. Now we operate in 3 countries in the US, Norway, and Chile. The idea of the company is to be able to combine the latest in software technology and machine learning technology from Silicon Valley with the fish farming knowledge from Norway and Chile. And so it's both the technologists that we have in Silicon Valley, but also working with the aquaculture and biology experts from the leading fish farms. So this is both in Norway and Chile. And so far we've sold and tested our technology with more than 20 customers. And this has largely happened over the last 2 years with our growth to almost 45 employees across the 3 countries. In terms of our mission, it's really to make fish farms more sustainable with software. This involves us focusing on a couple different focus areas. Certainly we have the system measures biomass and average weight. We also are able to do automatic lice counting. We also have the fish ID, so we can recognize the fish and also determine different aspects of fish welfare. And we use this data together to be able to help with analyses around growth, feeding, fish welfare, and ultimately allow the farmers to be more sustainable, but also to have a more efficient and profitable production. The idea behind our system is it's a camera-based system. It goes in a cage and takes pictures of the fish. And the idea that anything that is visible on the fish, we can identify, whether that's caligus, whether that's a wound, a deformity, even the weight of the fish, the identification of the fish. If you can see it on a fish, then we can measure it. This again is all driven by the biology of the fish. So we work very closely with fish health biologists to develop the algorithms, and really inspired by the technology that's come out of Silicon Valley and be able to apply it to aquaculture. So how does the technology work? We have the camera. The camera goes in the cage. There's one camera per cage. The camera has two lenses. Like us, we have two eyes. We can see the depth and take pictures of the fish. Those pictures are processed through a data pipeline through the algorithms, and then that goes to be able to be on a dashboard where you can see all the information and use that information to make decisions at the farm. The camera also has other sensors, so it can also measure temperature, oxygen, other environmental parameters at the farm that may be of interest, and also can be controlled the position via winch in the cage. The idea is that this single camera can measure everything that you need to measure in a cage. So it can also have version with the feeding camera, so you just have everything together in a single camera to monitor everything that you need to know about the fish. So in terms of let's take a look behind the scenes in terms of what our algorithm sees. So we have certainly a picture of a fish in a pen. The algorithm here is identifying different body parts on the fish. With this, it's creating a 3D model and being able to determine the weight and shape and size of the fish. And we do this for thousands and thousands of fish throughout the day. Here, we're able to use it for biomass estimation, but we can also use the same technology to count the caligus and other fish health factors on the fish, and ultimately provide that intelligence to the farmer. To date, we've processed over 175 million fish, so we're processing like a lot of data, and this is having worked with over 20 farmers over the last 2 years to develop this technology, and so we have a very, very precise estimation of the weight and the sea lice from processing all these different fish. So as I mentioned, from a picture, we can determine certain aspects. One aspect is the weight estimation. So here, for each of the sizes in the pen, we're able to determine the different weight classes and the distribution, which allows you to understand how the fish are growing. This also allows us to understand different populations in the pen. So here we can see the individual weights, but also the low K-factor weights and low weight fish, which are the loser fish in the pen. And so we can identify different subpopulations and how they grow. We can also connect this with the lice counts to be able to identify lice counts in different places. And the idea is to be able to combine growth, weight, feeding, lice, fish health, and all together in a single analysis platform where you can understand how the fish are growing in response to sea lice and other factors in the pen. One aspect that's also fairly interesting is that we can use the spot patterns on the fish to be able to create a unique fingerprint of the fish, which we call fish ID. This, in this case, allows us to prevent double sampling of the same fish, both in the weight and also the caligus counts, to make sure that we're getting a unique set of fish. But also we can use this to track individual fish over time and see how they grow, how their caligus develops, how their weight develops, and do this for all the fish in the pen. So the weight product we tried both in kind of regular facilities and in production cages, but also in individual pit tag studies where it's 98% accurate on pretty much like all the harvests that we've done so far. But more generally, I want to talk about kind of how we use the technology for caligus and how we measure fish welfare in a pen. And just keep in mind, I mean, if you're taking a picture of the fish swimming around, we're doing a lot of things at the same time. We're identifying fish in the image. We're counting caligus on a moving fish. We're also trying to identify that fish. identify the weight, identify health parameters, and this is all happening at the same time. And so there's a lot of complexity behind the scenes that's enabling this. We're also doing the computation on the camera. So for limited bandwidth regions, such as in Chile, we're able to process on the camera to reduce the amount of bandwidth that's uploaded and ultimately allow a farmer to see this all together on a dashboard. So again, the idea being that if you can see it, we can count it. Sea lice, as we know, is not always easy to detect. They can be very, very small. Sea lice in Norway, we're detecting down to millimeter size sea lice and being able to do it on the moving fish. And as we know, this can be quite challenging, even for manual counting. So just in terms of comparing the process, so on the top, we have a typical manual process where you're catching the fish, looking at each fish one by one, and being able to write that down in a journal and do that for 10 or 20 fish to understand the lice counts. Here, again, we're using a camera, but instead of the person looking at the fish, the algorithm's reviewing it. We also have a fish health biologist that's overseeing the system to make sure that it's counting the right sea lice, so every sea lice count is verified, and then ultimately that data is in the application where you can see it virtually. And so instead of having it in a journal and manual, everything is fully automated, which reduces the amount of work to understand the development in the pen, and you get a more real-time development of how the sea lice is growing. For us, the biggest news kind of recently was a couple weeks ago. We were the first and only company to have automatic lice counting approved by the Norwegian government via dispensation. So we had 2 fish farmers that have been approved so far via dispensation in Norway. So instead of doing a manual counts, they can be able to use our unit for automatic lice counting. This is based on the experience of us having operated at over 20 sites in Norway for the last 2 years, and something where now farmers who apply with us go through a very quick application process to use our technology, and then they can submit our counts to the government, which saves these farms from needing to manually go out and count each week. This is, again, based on a lot of science. We've done specific control studies where in a tank, we put a fish in, we take a picture via the camera. We also then do a blind study where someone counts it. And we've seen that we've been able to achieve 80 to 90% accuracy in counting the different sea lice. So overall, very, very, very accurate in terms of counting the different stages of the sea lice. So I just want to show you actually what the algorithm does. So here we have an image of a fish. We have algorithms that detect the small sea lice on the fish. Maybe it's too small to see on the camera, but then we're counting it and being able to quantify the number of sea lice on each fish that swims by the camera. We're then being able to then see where the different detections are on the fish itself to be able to determine a representative count on the different stages. And you can also see the attachment points and use that to understand how the lice is developing for the different stages. We then use this information to develop a real-time count. So instead of counting 10 or 20 fish a week, we're counting 10 times that every day, and we're getting a real-time development of the sea lice count. Just to give a comparison, this green line here is a manual count. So each week they're counting 10 or 20 fish. And here, this orange line is us counting every day. And you can see we have a much clearer understanding of the development patterns in a pen. And in here, they're doing treatments. And so here they had to do a treatment 2 weeks after the last treatment. But if they could see the real-time development, then a farmer could have taken action earlier to reduce the number of treatments over time. And so for the first time, you have real-time view into how the caligus is developing to be able to take better actions around treatments. What we're also doing, so the idea is better lice data equals better and fewer lice treatments and overall better welfare for the fish. Not only because you're not handling the fish, but you also have a lot more data to take decisions. Here's an example where we have a cage with, we have a site with 5 cages. We put a camera in each cage and we're monitoring development over time. We're able to see the infestations develop in 3 of the pens, but the other 2 pens are not infested. And then over time, these 3 pens infect the other 2 pens, and then they become the same lice infestation. And then they have to do a treatment, and it's still over the legal limit. And so for us, if the farmer knew beforehand that it was only 3 of the cages that were infected, they could have chose to treat fewer pens, which would overall then prevent these pens from infecting the other 2 pens. And so you get more targeted information to be able to do treatments, which overall improve the growth and welfare of the fish, and based on this information, which is based on the real-time development of the lice. Well, although the farmers in Norway are using this to develop much better treatment strategies and overall determine what type of treatment to do based on what type of lice is on the fish. One question you may also have is, okay, like sea lice may have like different shapes and sizes and colors. How do you detect all of the different different variations? This is where the power of the machine learning comes in, where it can detect different types of sea lice in different colors and shapes. Here we have a very clear sea lice, and the algorithm was able to pick this up. And so this is really the power of the machine learning, where we can teach the algorithm to identify all different colors and shapes of the sea lice and identify it in different conditions. In Norway, there's also 2 different types of sea lice that might attach to the fish. And here we're also able to differentiate different types of sea lice and provide different types of counts over time to ultimately be able to determine proper infestation levels in a pen. So instead of talking about this, I just want to show you exactly what the platform does. So I just want to give a short demo. So let's see if I can pull this up. So hopefully you can see the application page. So this is one of the fish that we have detected, and here you can zoom in and see the different lice that were detected on the pen, detected on this fish. They're very small. Let me just go to the main site. So here you can be able to see the different pictures in the pen. I guess it's dark in Norway right now, but here we're able to get an overview of both the weight in the pen, the average weight, the number of fish in the pen, the growth, and then to be able to use this to understand growth over time, as well as see kind of individual fish that have developed, and the sampling. And the sampling is very important to get representative sample. We can see the weight distribution in the pen and the percentage in the different weight buckets, and then correlate it with the development of the sea lice over time. So here we're seeing the different stages of the sea lice and how each of them are developing, and then using that to develop a good idea of the lice pressure and use this for treatment decision support. We're able to also compare development across different pens to see how spatially how it's developing in the different cages, and be able to use that to make a better treatment decision, as well as have idea about the projection of the future development of the sea lice counts. In Norway, as I mentioned, every week they have to report the counts. And so we're able to develop a report that the farmer can download that determines like the different levels of the sea lice. And then the farmer can download this and choose to report it to the authorities if they wish, which saves them from the need to do the manual counting. And of course, each of the fish that are detected, there's a photograph here. So every detection, you can verify that it was actually counting the lice in the right area on the fish. And so this is, again, is providing a much clearer development of the sea lice, much more scientific, and allowing for better treatment decisions. So yeah, let me go back to the presentation. So this is something where, as we know, Norway and Chile have the same challenges in relation to sea lice control. Norway, as we know, it's quite a big challenge, costing in industry almost like 10 kroners per kilo in terms of sea lice management. In Chile, annual costs are almost like 300 million US. And as kind of previously shown in the previous presentations, Norway farmers mostly focusing on mechanical controls, while Chile farms focus on therapeutic controls, which need to be done in a coordinated way. The idea being that right now, because we don't have the data, it's very difficult to develop tools to know the effectiveness of the methods to control caligus. Right now, if you do a treatment, it's very difficult to know, was the treatment effective? Am I going to need to do a new treatment in a couple weeks? Which pens do I need to treat? For the first time, we're able to provide that data and insight to be able to allow a farmer to better make that judgment. This also is important because in Chile, there's growing resistance of the parasites due to the drugs, and therefore greater infestation and losses. And by being able to understand sea lice counts and how they respond to different treatments, we can develop the best treatment strategies to avoid this growing resistance and be able to use the treatments that are most effective towards ultimately reducing the lice. This is also something from a process improvement standpoint, something that can be improved. So, of course, in each of the countries, there needs to be weekly samplings of the fish. This takes time. It's also something during, certainly during the Corona times, where folks, it's difficult and there's risk of infection. The idea that like if a camera is being able to obtain the sea lice counts, then there's no need for kind of workers to go out and to manually handle the fish. And so it just makes it a lot easier to get the lice counts that are required in both countries. And so this is, again, I want to emphasize, this is something that ultimately is just another way to count sea lice. And so of course, this information can be compared and consolidated, and then ultimately it's up to the farmer to determine what information they want to use. But in Norway, our systems, again, minimum kind of 10 times more than what they're doing now on a weekly basis every day. So we're capturing hundreds of samples for sea lice and thousands of samples for biomass, and being able to use that to provide insight to the farmers. So again, this is something in Norway that is here and now. So it's already been operating in Norway on 20 farms over the last 2 years. We're really looking forward to be able to count sea lice in Chile very soon. We launched in Chile earlier this year. As we know, sea lice in Norway are larger than the sea lice in Chile. And so there needs to be some R&D in terms of being able to detect smaller stages, though in Norway we are able to detect smaller stages, and so we should be able to detect the stages of caligus in Chile. And so this is something that certainly will be coming in Chile and that we can use. And and figure out how to best develop the technology for the Chilean market. Overall, we see automatic sea lice in Chile, automatic sea lice counting as advancing the industry. There's a couple points here. One is with automatic lice counts, now you can know the effectiveness of the treatments and also consequently the resistance of the parasites to certain drugs and be able to make better treatment decisions. It also reduces fish handling, improves sustainability, which certainly for animal welfare is important, and be able to use methods that are good for the fish. Since we can identify the fish, recall that we have fish ID, and we can also correlate it with the biomass information. We can also use it for genetics and nutrition, so be able to use this data to help develop fish strains that are more resistant to lice and grow better in lice conditions. Furthermore, also because, again, the single camera in the pen can measure everything, it also has sensors such as temperature that can then be able to use to correlate information between infestation and environmental conditions and ultimately make a better decision about what sea lice treatment to use. So in short, this is something where we're really excited to bring this technology to Chile to hopefully better understand the dynamics of infestation, how sea lice is developing, and help the industry advance and being able to bring better sea lice treatments and overall improve sea lice monitoring and development, and overall improve fish farming in Chile as we have done in Norway. And so, yeah, really appreciate you guys listening, and of course, happy to take any questions.
Thank you very much, Brighton. Honestly, a great presentation, a great tool. The technology, the R&D involved is mind-blowing, since it's not only a tool for one aspect of the aquaculture or salmon industry, but it covers a lot of gaps that we have right now for the industry and for also the authority who I represent. I'm gonna translate. Bueno, le estaba agradeciendo a Brighton su presentación. La verdad que es una herramienta que se ve fantástica en cuanto que cubre muchos aspectos y llena muchos vacíos necesarios para el desarrollo de la industria y también para la autoridad y nuestras expectativas y necesidades de vigilancia y control. Entonces, la verdad que muy, muy interesante.